is do one small thing to those graphs from yesterday, right? So if you guys were paying attention closely yesterday, what we said is we have sine and cosine curves, right? And what were we doing with those sine and cosine curves? Well, we were putting them on a graph, right? Then we went one step further, and I said, well, we can take those curves and we can stretch them vertically, right? We can turn the power up at the radio station and make the signal go out a little further, right? A little bit more power, okay? And what that did is it changed the amplitude or the what? Or the y values, making our graph taller, right? We also talked about how we could take our graph and reflect it, right? By putting a negative sign there, okay? So now the question is, well, what happens if I just add something to it? In other words, what if I, don't write this down, but what if I just did this? Well, think about the different, actually, let me put a different number. Let me put 2 versus this, right? Everybody agrees that this is what we did yesterday, correct? And you guys did a really great job of saying, okay, well, what does that mean? It means I take my sine curve, find the y values, and multiply them by 2. Well, what do you think you need to do here? You need to find the y values and not multiply by 2, but now add 2. So guys, if my graph is right here, and I say that I want to add 2 to this graph, what's going to happen? I'm going to go up 2 units. If my graph is right here and I say I want to subtract 2, it's going to go down 2 units. Is it going to stretch out anymore? No. Is it going to reflect at all? No, it's just going to what? Shift up or shift down. That's it, okay? So we're looking at vertical shifts. That's it. That's all we're going to do, okay? So if I did this to a sine curve, sine of x plus 3, we would expect our graph to shift up 3 units. We would expect our graph to shift up 3 units. So if this is my graph of sine of x, everybody agrees that that graph is the untainted version. It's the original curve of sine without anything done to it, okay? What am I asked to do? I'm asked to take this curve and add 3 to it, which means this curve is simply going to shift up 3 units. So what I'm going to do is I'm going to take those key points that I would typically what? I would typically plot these points for me to graph this, right? And I'm going to do what with those 3 points? Or with those, not 3 points, but 10 or so points. I'm going to simply shift them up 3 units, right? So this point right here is going to go up 1, 2, 3. And this point right here is going to go up 1, 2, 3. And I get a curve that looks like this. Y equals sine of x plus 3. If I look at the black curve, the original curve before I what? Before I shifted it, what's the range of the original curve? Range means what? Lowest to highest. What's the lowest value in this black curve? -1. And the highest? +1. So what is the range of my new blue curve? What's the lowest? 2. And the highest? 4. Does anybody see sort of a trick right there to find the range if I didn't graph it? Yeah, does everybody agree that all sine and cosine curves have this range? If I don't what? if I don't do anything to them, right? So what did I do to this one? I simply moved it up 3, right? So if I take -1 and I add 3, what do I get? 2. And if I take 1 and I add 3, what do I get? 4. So an easy way to think about it, right? So that should make some sense until I do this, right? Until I do this, until I throw a couple of things at you, right? What did I do here, guys? I threw a 2 in front. Give me a word for that. What does that 2 represent? Started with an A. Amplitude. And then this is my vertical shift. All right, the way I'm going to do this problem, guys, is I'm going to do it in 3 steps. Okay? These are my 3 steps. Step number 1. What kind of a curve am I supposed to graph? Sine, cosine. Okay, so I know I need a cosine of curve. I know I need a cosine of x curve. So I'm going to graph that. Then the next thing I'm going to do is I'm going to graph this. Which is what? Which is the cosine curve with a change in the amplitude, right? It's what we did yesterday. And then what am I going to do? Then I'm going to take that curve and I'm going to shift it up 1 unit. So I'm going to do this in 3 steps, which means my graph right here is going to have 3 distinct graphs on it, okay? So I need to graph cosine of x. So if you guys are sitting there and you're like, well, I think I know how to do it, but I'm not sure, what's a way that you can be sure? Well, we're going to really quickly sketch our unit circle. And which values do I want? X's or Y's for this problem? X's. Why X's? Because I'm dealing with cosine. All right, so we're going to start graphing cosine. We're going to start at 0. So what am I going to do at 0? What am I going to plot? Where is 0, by the way? Right here, correct? That's my 0 degrees. So what am I going to plot at the 0 on my curve? 1. Okay. And then if I go 90 degrees forward, what am I going to plot? 0. And then if I go another 90 degrees forward, what am I going to plot? And then another 90 degrees forward. And then another. Okay? I should do that in black. All right, cool. Hazy, what if I went the other way? What if instead of going in the positive direction, I went the negative direction? From 1, I would go to 0, and then 2, and then 2, and then 2. Boom. And so this is our cosine curve. All right, so based on yesterday's lesson, right? And you guys did a great job with that. By me changing the amplitude, what points don't change on this curve? The x-axis, the x-intercepts, the roots, right? So I know that this one stays, and I know that this one stays, and I know that this one stays, and I know that that one stays. Why do those not change? Because what are the y values of those? 0, and what's 0 times the amplitude? 0. Okay. This is 1, right? 1 times the amplitude is 2. This is -1. -1 times the amplitude is -2. And then +2, and then -2, and then +2. And this is my 2 cosine of x curve. Sweet. And then what am I going to do to that curve? I'm going to take all those points in blue and simply move them up 1 unit. So all of those blue points are going to go up 1 spot. Now I understand, guys, that for your paper it looks a little bit confusing, primarily because of what? Why does yours look a little bit confusing compared to mine? Yeah, yours is probably in one color, right? So what I did there, guys, is I really wanted you, Trinity, to see the progression, right, of how we take this and we morph it into the red one, right? And that was a 2-step process. Okay, so guys, if I had this red curve in front of me, okay, and I asked Jaden to go up there for a minute, Jaden, I want you to cut that red curve in half horizontally. Yeah, I want you to cut that red curve in half horizontally. Where would you cut it? Right there. So you would start, show me where you were, right? Watch this. Want to see how, all right, so go ahead. So just go this way. Keep going. Right here? Yep. Good. I agree. Right? I agree. That would cut it in half, right? What's the thought process? What's the highest point? What's the lowest point? Where's the middle of that, right? Well, guess what? If that phrase made sense, then what this line is called is going to make sense. This line is called the midline. And do you know how you can find the midline? It's actually extremely easy. The midline is going to be, ready? The average of the range. The midline is the average of the range. So on that red curve, guys, what's the lowest point on the red curve? -1. What's the highest point on the red curve? -1 to 3, right? So if I asked you guys to find the midline, I said that the easiest way to find the midline is to find the average of the range, -1 to 3, right? How do you find the average of 2 items? Add them together, and then divide them by how many items you have, right? So this gives me 2 over 2, which is 1. So the midline is y equals 1. Now, immediately, you're going to ask yourself, great, Picardo, what's your point? Right? Great. What's your point? Well, my point is this. Is anybody, and you should be, does anybody look at this curve up here and say it's kind of annoying that I have to do this in 3 steps? Right? So what I'm going to show you here is how to do it in 1. Okay? I'm going to show you how to do it in 1. Guys, what did you notice about the midline compared to the, compared to that? The midline for this was y equals 1, right? What does that match up with? How much I shifted up, right? So guys, as a word of advice, the midline will always equal the vertical shift. Your midline will equal your vertical shift. Is that cool? Your midline will equal your vertical shift. So if I look at this first example here in blue, I have two questions to ask you about that. Question number one, what is the amplitude of 4 sine of x minus 2? 4. What is the vertical shift? -2, which means the midline is -2. So Jaden, here's what I'm going to do. I'm going to start off by plotting what you showed me a minute ago, right? I'm going to go to -2. And I'm going to plot it. There's my midline. Okay, here's where it all comes together now. Ready? What is the amplitude of this? 4, which means that there are going to be points, ready, that are 4 units above the midline and 4 units below the midline. Because what does the midline do? It takes the curve and cuts it in half. And if it has an amplitude of 4, that means from the midline, I got to go up 4 and down 4. Otherwise, it wouldn't have cut it in half. Okay, so how is that going to help you get this on the graph? Well, here's how. If I was to do, you guys are going to love this. We're dealing with sines, so I know I'm dealing with the y values now, right? All right, so I'm looking at my y values. Ready? This is where it's going to get cool. At 0, what should my y value be? 0, correct? So at 0, I need to plot 0, correct? But hang on, stop, wait 1 second. What did I do to this graph? I shifted it down 2 units. So instead of starting at 0, what's 0 times 4? 0. What's 0 minus 2? -2. So what does that mean? That means I have a point here on my midline. All right, now we're going to go to 90. What's the value of sine of 90? 1, correct? What is 1 times 4? 4. What is 4 minus 2? 2. So at 90, I'm going to go to 2. Does that point make sense in terms of what I said was going to happen? Why does it make sense? Because this point is 4 units above the line, correct? Okay. Now if I go to 180, what's my sine value? 0. All right, sine of 0 is 0. 0 times 4 is 0. 0 minus 2 is -2. So now I'm back here. If I go to 270, I'm at -1, right? 4 times -1 is -4. -4 minus 2 is -6. That's going to put me here. You do the last point, you're going to wind up back at -2. I want you guys to think about something, and I'm going to say something that might confuse you. I hope I don't. Steven, ready? When we do this, I want you guys to treat this midline like it's the what? Like it's the x-axis. Because what happened here? At 0, I was at 0, right? Where did I plot a point? On the midline, correct? Then instead of going to 1, because the amplitude was 4, I went 4 units up from the midline, didn't I? Then I went back to 0. Then I went 4 units below, and then I went back up to 0. So if you guys had to guess where that next point's going to be, am I going to put this next point up or down 4 units? Down? Which one? Down. Then where do you think the next point's going to be here? Is it going to be up? Is it going to be down? Or is it going to be on? It's going to be on. Because it's going to take on that shape, right? And then where's the next one going to be? Up, down, or on? Up. And then where's the next one going to be? Up, down, or on? On. Yeah, so once you create your first cycle, the rest is pretty easy to do, isn't it? There's your curve. There's your curve. Now, so far, Jelani, you got 2 ways to do this. Way number 1 is to do it like we did on the previous page, which is do it in 3 steps. Way number 2 now is to create your midline and then use your circle to create your points. That's way number 2. What's way number 3? Way number 3 is to use the calculator. So let's do this last problem here with our calculator. So I want to graph -2 cosine of x plus 3. Now, we talked about this yesterday because there were a lot of weird things that we had to take into consideration, right? -2 cosine of x plus 3. All right, so we're going to create a graph. -2 cosine of x plus 3. And I get this. And we feel really good about ourselves because it looks like a squiggly up and down thing, so that's great. But we know that there are some limitations. So we know we have to go to our window to make some adjustments. What kind of things do we want to do? Well, the first thing you got to do is decide what mode to be in. What mode do you want to be in, radian or degree? Your choice, not a wrong answer. All right, Jane says degree. So what do I need to do if I want to be in degree mode? Well, the first thing I need to do is what? Put a degree on the x. Well, that sounds good, Jane, but you just messed up everything because now it looks like a flat line. Why? I got to change the window settings, right? And what do you want to change the window settings to be? -360 to 360. Where'd that come from? Just out of the blue? Or because you remembered me doing that yesterday? You remember me doing it yesterday. So why did I choose to do that yesterday? Because I looked at what? I looked at this. That was what they wanted me to graph, right? They wanted me to graph from -2 pi to 2 pi. That's why I chose those values. All right, so now I can look at it. So that's what it needs to look like on my paper, right? But how do I get from here to the paper? Well, what do we like to go to? Table. How do I get there? Control T. All right, and so I have a table. What's inconvenient about this table? It goes by, these are jumping by ones. Do I want to graph every 1 degree? No, I want to graph every 90 degrees. Why every 90 degrees? Because that's what the jumps are in the unit circle, right? So now what am I going to do? To change that, I go to menu, and I go to table, and I go to edit table settings. I want to jump by 90 degrees each time, right? Where do you want your table to start? I could start it at 0, right? What would be even more convenient? Where does the graph start? At -360, right? So if I want to be convenient, I can even make that -360. And now what do I have? Oh, I got a whole chart of what to plot. So to plot this, I need to start at -60 and plot 1, 3, 5, 3, 1, 3, 5, 3, 1, 3, 5, 3, because that is the pattern. 1, 3, 5, 3. 1, 3, 5, 3. Okay, let's do it. So I need to plot 1, 3, 5, 3, 1, 3, 5, 3, 1. And that is my -2 sine of x plus 3. So you have 3 ways that you can plot one of these. With the calculator, by doing it as a 3-step problem, or by using your midline and the range to create your graph. State the range. So the range of the blue curve was -6 to 2. And the range of the red curve is 1 to 5. What was the minimum value? I don't even know why this is a question, Sanity, because it's so simple. If you look at the range, doesn't the range give you the minimum and maximum value? So of the f, what's the minimum? -6. What's the max? 2. And on the red curve, what's the min? And the max? 5. So I think the reason that they give that to you is they want you to find the midline, right? I want you to find the midline. All right, I'm going to end there. I know there's this problem at the end. I'm not going to do that problem today. All right.